Jai Hind everyone, myself Dr. PANKAJ GOEL, Assistant Professor in Electronics and Communication Engineering Department at Ajay Kumar Garg Engineering College. Today we will discuss about MGS and EGS growth process in VLSI technology subject. As we all know that in VLSI, the key product, the key material that we use, it is semiconductor. And in semiconductor materials, the most commonly used material is known as silicon material. So, in this lecture, we will discuss about how we produce silicon which can be used to make the silicon wafers or substrates. Now, we have two steps that are involved to prepare a crystal wafer, silicon crystal wafer from the raw silicon material. And these two steps are abbreviated here as MGS and EGS. The MGS stands for metallurgical grade silicon and EGS stands for electronic grade silicon. In this presentation, we will discuss about the introduction, metallurgical grade silicon, its schematic diagram, the electronic grade silicon and the schematic diagram of CVD reactor for EGS production, and in the last, the references that I have used to prepare this presentation. As we know that silicon based devices constitute over 95% of all semiconductor devices. So, we can understand how important this semiconductor material is, that is silicon. Now, there are many reasons why silicon is so abundantly used in semiconductor industry. The first advantage why we use silicon is available in abundance in nature and therefore it is less costly as compared to other semiconductor materials like germanium. So, the low cost of silicon is one of the important reason why we use silicon. Second, as we know that the band gap of silicon material is 1.1 electron volt, whereas the germanium has a band gap of 0.66 electron volt. And this lower band gap of germanium creates a bit of problem for it, that it exhibits high junction leakage current. So, that is why in many applications we cannot use germanium because the leakage current is high. The third advantage of silicon is that the silicon devices can operate up to 150 degrees centigrade, whereas germanium can be used only up to 100 degrees centigrade. Germanium can be used only up to 100 degrees centigrade, whereas silicon can be used up to 150 degrees centigrade. So, these are the three main advantages of silicon: low cost, low junction leakage current and its use at higher temperature. Due to these three advantages of silicon, silicon is used extensively in semiconductor industry, and therefore it is important to understand the silicon production process, how to get the electronic grade silicon that we can use in manufacturing of various semiconductor devices. So, let us start. The first one is metallurgical grade silicon. This metallurgical grade silicon is produced in a submerged electrode arc furnace, and this MGS is produced in a furnace at a very high temperature. The raw material that we use to produce the MGS is known as quartzite, which is a compound of silicon dioxide SiO2 and silicon carbide, which is a relatively pure form of sand and carbon. So we use quartzite and silicon carbide as raw material to produce the metallurgical grade silicon, and the chemical reaction that we use in the furnace to produce MGS is given by SiC, which is solid, plus SiO2, which is also solid, which gives you silicon plus these byproducts in the gaseous form, SiO and CO. This process is very power intensive, requiring about 13 kilowatt hour of energy per kg production of MGS. 1 kg production of MGS require 13 kilowatt hour of energy. And this silicon that is produced is in the liquid form. It is drawn off the furnace and it is solidified, and the purity that comes with it is about 98%. Here we can see the schematic diagram. Here we can see the temperature inside the furnace that is used to produce the MGS. See, 1600 degrees centigrade to 1780 degrees centigrade. This high temperature is used, and at this high temperature the reaction takes place between the quartzite and silicon carbide, which gives you your MGS in liquid form, which is discharged here, and these are the two byproducts, SiO and CO, in the gaseous form, and these products are left through this way along with the water vapors, and the MGS is taken out from here. So this is how MGS is produced using raw material quartzite and silicon carbide at a very high temperature, and the output of the reaction is silicon in the liquid form and SiO and CO in the gaseous form, which are taken out. Next step, the MGS which is used, the MGS which is produced in this previous step has a purity of 98%, and this MGS is not good enough to be used in semiconductor materials directly, so it need to be further processed to get the electronic grade silicon. So our next step is to get EGS from MGS. Now this MGS, which has a purity of 98%, it is good enough to be used in making the metal alloys, but not sufficiently pure in the manufacturing of solid state devices. Now to get EGS from MGS, the first step is we have to pulverize the silicon mechanically. Now what is pulverize? Pulverize is to crush the silicon into fine particles. So the first step is to pulverize because in the first step we have solidified the liquid silicon and now we have to pulverize the silicon into fine powder form, and then it is reacted with the anhydrous hydrogen chloride to form the trichlorosilane. Pulverized silicon in the solid form and reaction taking place with the HCl gas gives us trichlorosilane, SiHCl3, along with the other product. Now this reaction takes place in a fluidized bed at 300 degrees centigrade. At this point, purification process occurs. The impurities are taken away. The trichlorosilane is a liquid at room temperature. Its boiling point is 32 degrees centigrade. So below 32 degrees centigrade it is a liquid, and above 32 degree it is gas. Now here the purification is done by a process known as fractional distillation. The electronic grade silicon that we are producing from MGS has a very important characteristic, that it is a polycrystalline material in nature. It is a polycrystalline material in nature. And it is a raw material, it acts as a raw material for the preparation of single crystal silicon. Now, as we know that EGS is a multi-step process. In the first step, what we have done, we have obtained the trichlorosilane gas from the MGS in the previous step. Here we can see, first we pulverize the solid silicon into the powder form, and then reacting it with the HCl gas, we got the trichlorosilane. Now this trichlorosilane is further required to be processed. This trichlorosilane, when we obtain from MGS, it need to be purified using fractional distillation, and then in a chemical vapor deposition process we obtain the solid silicon and a byproduct of HCl. This is the reaction that is taking place inside the chemical vapor deposition process. Let us see here, this is the CVD reactor that is used for the EGS production. Here the raw material that we are using in this reactor is trichlorosilane, which we have obtained from the MGS. After pulverizing it and reacting it with HCl at 300 degrees centigrade, we have obtained the trichlorosilane. We did the fractional distillation to purify it, and then this is given as a raw material in this CVD reactor to obtain the purified form of silicon, which is known as EGS. Okay. Now here in this graph, in this figure, we can see we have a slim rod of 4 mm diameter. This is the rod of silicon material and very thin, about 4 millimeter diameter. Why we use this slim rod here? See, this slim rod serve as a nucleation point for the deposition of silicon, and this complete process takes many hours and results in rods of EGS which are polycrystalline in structure, and these EGS rods have a diameter of around 0.2 m, 0.2 meter, means about 200 mm. 200 mm. Whereas we can see here the slim rod that we have used as a nucleation point has a diameter of only 4 mm. So this 4 mm rod is changed to around 200 mm EGS rod. Now in this figure also we can see here, this is our slim rod, very thin of about 4 mm, and around this slim rod, here we can see around this slim rod, the silicon that is generating from this trichlorosilane gas is deposited over this slim rod, and the diameter of this slim rod keeps on increasing and it can go up to 200 mm. Okay, we can see this is the slim rod, and this shows the diameter of the EGS rod that is obtained when trichlorosilane is converted into silicon, and this silicon is deposited over this slim rod, and the diameter keep on increasing and it can go up to 200 mm. And also note that the length of this EGS rod can go up to several meters. So you can imagine the size of this CVD reactor. Now this EGS rod that we have obtained can be cut from these rods as single chunks or nuggets. This is the power unit, this is the residual gases that comes out from here, silicon get deposited here and the residual gases come out from here. This is the graphite holder and the insulation. Now in the complete process of EGS production starting with MGS is shown in the figure. This figure has been taken from a very famous book written by SMZ on the subject VLSI technology. Here we can see, here we have a silicon which is MGS, that is 98% purity. Now this silicon, MGS silicon on a fluidized bed at around 300 degrees centigrade is reacted with HCl to give us trichlorosilane. Now trichlorosilane, before it is given to the chemical vapor deposition CVD reactor, before trichlorosilane is given to the CVD reactor to produce the silicon EGS, we do the distillation process. Here the low boiling impurities are removed and the purer form now goes to the CVD reactor. The impurities are, low boiling impurities are removed in the distillation process and the purer trichlorosilane goes to the CVD reactor, and here when trichlorosilane gas is converted back into the silicon liquid solid silicon form, this silicon, which is much purer than MGS, is known as EGS, electronic grade silicon. Now further, the byproduct of this CVD reactor process are further processed and their useful materials are recovered. Like here we can see the chlorosilane is recovered. This is chlorosilane, and then here HCl is recovered and H2 is fed back to the CVD reactor process for the reaction. So this is the schematic diagram of the production of EGS from hydrogen reduction of trichlorosilane. So here this complete schematic diagram has been divided into 4 steps. The first one is trichlorosilane production in the fluidized bed at 300 degrees centigrade. Then the purification process happens, and after that the CVD reaction happens, and then we have the recovery process in the end. Now one more important alternative process that can be used to produce the electronic grade silicon is using a silane gas instead of trichlorosilane. So from MGS to reach EGS, either we can use trichlorosilane gas or we can use silane gas. If we use silane gas, then the reaction that takes place in the CVD reactor to get the silicon, the reaction is given by SiH4 plus heat. It gives you Si plus 2H2. And the advantage of producing EGS from the silane are potentially lower cost and less harmful reaction byproducts. So these are the advantages. We can see here the process that we use to get the electronic grade silicon from the silane gas is known as pyrolysis of silane, is known as pyrolysis of silane. What is pyrolysis? Pyrolysis is the heating of any material in the absence of oxygen. So we have discussed that to get the EGS from MGS, first of all it is a multi-step process. First of all we have to get the trichlorosilane from the MGS silicon in the fluidized bed at 300 degrees centigrade, where the reaction takes place with HCl, and then this trichlorosilane is purified using distillation process, and then this purer trichlorosilane is given as an input, as a raw material to the CVD reactor, where we use a slim rod which acts as a nucleation point, and across this slim rod the silicon get deposited, and its diameter can be as high as about 200 millimeter, that is 0.2 meter. Then to get the EGS from MGS, another process may be that instead of trichlorosilane we may use silane gas, SiH4, and the advantage of silane is that it has potentially lower cost and less harmful reaction byproducts. and the process that we use to produce EGS from silane is known as pyrolysis of silane. Where what is pyrolysis of silane? It is the heating of the material in the absence of oxygen. The reactions that takes place is mentioned here. SiH4 plus heat will give silicon in the solid form plus 2H2 gas. Now in the last, in the silicon wafer production, here we can see that MGS that is used give us the chlorosilane, which is then purified using distillation process. Pure trichlorosilane is used to is given as an input in the CVD reactor, where H2 is another input, and here the solid silicon is obtained, which is known as EGS, and this EGS is a polysilicon crystal. Now this polysilicon crystal EGS act as a raw material to obtain single crystal silicon, and this single crystal silicon is obtained by a process which is known as CZ process. And this single crystal silicon that is obtained here from the CZ process can be used to produce the semiconductor wafers. So for today we end our topic. The books that I have referred for these topics is SMZ. The book title is VLSI Technology from McGraw-Hill, and the second is book written by Saurabh K. Gandhi, and the title is VLSI Fabrication Principles from Wiley India Private Limited. Thank you very much.